Pute, let's start. So as I promised, I have already summarized the internet and email lesson last day. And actually, I promised you to summarize the SDLC lesson also. And programming lesson we have already done. Web design and using multimedia already done. There are some minor parts to be completed. And plan is to summarize SDLC lesson today. After that, we will be starting the multimedia lesson. Will take closer to 2 months to finish, and as well as this one altogether, it will take 2 more months to maximum 3 months to finish the syllabus. But the examination is, as I know, it's postponed to May, so we have enough time to start our paper class after this, because I was thinking to start the paper class this month, but considering the situation, so we'll be starting the paper class after finishing the theory class, right? Because we are like too early to finish the syllabus. Don't worry, I'll be finishing on time and then move to the paper class. So let's move to the lesson now, SDLC. A very quick discussion will be there today, as we have already done this and we need to just remind things that we have learned previously. Okay, the first term that we need to learn, that we need to remember, is a system. So what do we, so can you tell me what's the meaning of system? Yes, Lavanya. So what is system? What's the meaning? System is, yes. So maybe I can give you some examples. Just think about our systems that we are using now. Respiratory system, digestion system. If you take respiratory system, so there are components. So parts, what are these? Nose is a component, throat is a component, lungs components. So those are components of this respiratory system. Not just that there are many, but all these components are working together, interacting and working together. So that is also a feature of a system. So feature number 1, it is a set of components. Feature number 2, interactively working together. Feature number 3, there's a common goal. The respiratory system, common goal is respiration. The respiratory system, common goal is respiration. So system is actually a collection of components that interact, or you can say collection of connected components. Better you add that term, collection of interconnected components. I will add that. Collection of interconnected components. System is a collection of interconnected components that interact together to achieve a common goal or specific goal or specific task. So please add these terms, very important. Collection of interconnected components that interact and work together to achieve a specific goal. So see the diagram below. It has some sensible picture. So the first thing is like some components, but some components will not make system. So it is just components. Having components will not create a system. If it need to be a system, the system needs these components to interact and interconnect. So you can see this is interconnected and interacting. Proper places. You can't fix head to hand, hand to head, wheels to the left hand, right hand. So you can't fix like that, right? In a system, you have to fix these into proper places. So this definition you need to remember remember correctly. System is a collection of interconnected components, properly interconnected components, and interact together to perform specific goal. Example, respiratory system. Example, computer system, school system. These are examples. Okay, so if I ask another question, so there are few type of systems. So systems can be a system. System can be one. It can be a manual system. It can be a mechanical system. It can be electromechanical system. And it can be electronic system. And it can be a natural system or biological system. So what are these types? Natural system is a system that is there with the nature. Example, our respiratory system is natural system. Ecosystem, solar system, these are natural systems. It's not synthetically, it's not artificially formed, it's natural. So what is manual system then? Manual system. Yes, Timasha. Manual system. What is manual system? Natural system, these are biological, which can be seen in the nature. Manual systems. Okay, can you at least give me a few examples for manual systems? I need you all to talk, right? So please try to talk. Maybe you feel sleepy. So shall I put this class a little earlier if you feel sleepy? I can put the class around like 4 p.m. in the evening, 4 to 5:30. Because now that we are not doing the single medium class, I can shift the class to that time. Tell me if you are okay, then I can shift it. Maybe if you feel sleepy, that would be a solution, then you can sleep early. Right? Otherwise, you're not talking, right? Manual systems are the systems, the man-made systems, but these systems are not using any equipment. So basically using manpower. Example, your attendance mark in the school, register, school register, is example for manual system. All bus ticket system, then there are all bus ticket system which the conductor used to write down in a book, ticket manual system. School school register manual system. And maybe so the systems used by this drama niladari, drama seva, that is also a natural system. 7 to 8:30 Lavanya, it's a bit difficult because like we are having a Sinhala medium class for 11, grade 11. That's the reason. That's the reason why we can't shift to the 7 to 8:30. But there's a possibility I can shift it to, because grade 10 Sinhala medium class is not there. Therefore, we can shift it to 4 to 5:30. If it is possible, please let me know. Okay, manual systems are fully man-made, no machineries are used. So it is basically hand, pens and all. So your registration, student registration system, the school student register, maybe sometimes there are manual library systems, old bus ticketing system. These are manual. And so can you remember the system that we have used in the COVID-19, contact tracing? That is also a manual system, right? Because like there was electronic system, but people use manual system mostly. Most of the places still in the government places, they are using these manual systems. Mechanical systems are using machines, like typewriter is a mechanical system. There are mechanical farming, mechanical devices used in farming, and electromechanical, mechanics plus electronics. So farming also electromechanical, driving the vehicles electromechanical. And there are fully electronics like computers. So electronics using electricity. So these are different type of systems available. Discuss about that, and I have summarized. If you want, just take a screenshot of this. System is a collection of interconnected components work together, and there are different systems. So basically, information system, any system will take input. That is a compulsory component of a system, and it will be processed. And intention of any system is to produce an output. Any system will have input, process, and output. But especially the information system use data as input, and it will process it to produce meaningful facts, which are called information. Meaningful things, information. Data, process, and meaningful information. This is information system, IS. And this is generally S system. Any system has 3 components: Input, process, output. In input information system, it is data, process, and information. So that is what happened in information system. So this is the summary of the lesson that we are going to learn today. Actually, we have already learned. We are summarizing this now. Right. I'm closing, right? I'm just erasing. Have you taken the screenshot? Okay, great. Right. Then here you can see the basic elements, input, process, output. I already discussed. In a school system, so objective or the output is basically producing valuable citizens to the society, which is not happening actually. Don't know, right? It is not perfectly achieved, but up to some extent it's achieved. Input, children. Process, teaching them and training them. Output, good citizens. Any system has this. But information system, so only thing is the data will be the input and information will be the output. Sometimes even information can be put in as inputs, and information can be processed to produce some other information. So that is also possible, right? Even data vitarak neveyi, data process karna vitarak neveyi, information process karanna not. Anyway, we consider basic facts as data and meaningful facts as information. Process is intermediate task. And it can be a manual system where everything happens manually, right? You can see the student registry in your school. You enter that, you write that. So process like finding the index number, input into the personal file, so keeping the personal file. So progress, the report book, progress report, record book. So that is also a manual system, right? But so there are issues in manual system. It can be less accurate. Accuracy can be low. Efficiency can be low. The fastness, accuracy, efficiency can be very low in manual systems. But here, so you can easily find, easily edit, easily manipulate, easily add record, and keep in backups. It's very efficient. You can take copies. You can automate, and fast reports can be given. Automatic calculations are there, which is more accurate than manual system. So let's compare them. Right, and this portable, it uses less space, and it is movable. It can be put online, right? Different, so it's the like distance independence. When you put online, now we are teaching online. This is electronic system. So this is distance independent. You can even join from Australia, doesn't matter. If your time permits, you can join this time. You are in Australia, but you can join. If you are in Canada, you can join. In Japan, you can join. Sri Lanka, you can join. Anywhere. It's location independent. Fast. Technological, you can watch the recording. So that is advantage. You can watch it again. So these benefits are there. Okay, then, so what are the differences? Mainly, so accuracy, minimum errors, accuracy. The other hand, accuracy. Efficient, fast, that is another thing. The manual systems are slow, but electronic systems are fast. And it can handle very large amount of data relatively. It can store in a very small space. මෙයාගේ තිබ්බොත් ෆයිල් ගොඩාක් ස්ටෝර් කරන්න කාමර ගානක් ඕන. මෙයාගේ ෆයිල්ස් ගොඩක් තිබ්බොත් සමහරට එක hard disk එක pen drive එකේ ස්ටෝර් කරන්න. It's very easy. And security can be ensured with passwords, backups can be taken, security can be ensured, and searching is like easy. Searching, manipulating records is easy. Right? Let me write that: record handling, processing, and searching is very easy and can be automated. So you know what to write in the other side, right? I'm writing this side, so you know the other side. So it is difficult and cannot be automated. So please write down that point also. This is this side electronic system or computer system. This side the manual. Okay. Right, then, so system development, we learned that this is in the previous day, one of the previous days we learned, system development is a cyclic process. System development is critical engineering approach. Why? Because so we work with information. Information is one of the most valuable economic resource in the world. It controls the world, it handles the world, it leads the world. So that is why it is one of the most valuable economic resource. So, you know, the rich people like Elon Musk and Bill Gates, Mark Zuckerberg, they are all products of this information technology. So IT productions, but they are the world's richest people. Jeff Bezos and all these people are the world's richest people. They work with information and they are working with information systems. Therefore, it is need to be high accurate, need to maintain high integrity, cannot maintain duplicates, wrong data, one data at one place, another data in another place. So both records are not matching. You can't keep that inconsistency. You need to make sure that consistency is there, the accuracy is there, the fastness is there. So Facebook, Mark Zuckerberg cannot say, now Facebook space is over, we cannot join more people. Never, never ever. Google cannot say now the searching facility is given, we can't provide searching to some more people. Never ever. They have to make room. If aliens come and connect, still Google need to allow. If aliens come and connect, still Facebook need to allow. So that is critical. Therefore, it needs a careful process, engineering process. So system development life cycle comes there. The first stage is problem identification as well as the requirement identification. So how we can identify the requirements? What are the methods? I'll make your life simple. One is observation. You can watch around. You can look around. That is one method of identifying requirement. If you want to develop a library system, go to the library and see what's happening there. So that is one way of getting information about the library. Can you name few more? What are the other methods other than direct observation? So what are the other methods? Yes. Direct observation is one method of acquiring information and identifying requirements. Anything else other than direct observation? Let's say you are given a task to develop a library system. You go to library and see using your eyes. You just watch. So what else you will do? Library එකට කියලා නිකන් බලලා එනවා සිස්ටම් එක හදන්න නැත්නම් තව මොන හරි කරනවද? මොනවාද කරනවා? Yes. Tell me guys. ඔයාලා library එකට කියලා නිදාගනින් වගේ මට පේනවා. Right? No one is talking. Come on. Library system එකක් හදන්න දුන්නොත් then Lavanya knows this because you have done this course even. If you are given a task to create a system, what you will do? Yes. Okay, Timasha. What you will do? You go and observe, that's all. Don't you ask questions from the librarian and the students? So you can do interviews, right? You can ask questions. Okay, these are the things that you can do. You can observe. You can do interviews. You can ask questions, written formats of questions. Maybe MCQ, multiple choice question, an essay, small essay, or written questions to identify the requirements. Interviews, talking with the people. Observation, just look around. Questionnaires, asking questions in a written format and collect those data. Documents, if there are existing documents, you need to collect. Prototyping. Prototyping is working model is created just to observe what's happening. The working model is created when requirements are not clear, when requirements are ambiguous, subjected to change. Oh, we use prototyping. So let me give you an idea. This is prototype biogas plants. A prototype biogas. Actually, it's a model. It's not actual plant, it's a working model. It shows So what need to be installed? Because the Coca-Cola bottle cannot be used as a biogas gas plant. No, this is a model, right? They're just using Coca-Cola bottle and some pipe to move the gas. This gas is then sent to a bottle, and through the bottle, there's a bottle, and so you have to watch the video and get an idea. I think you can see here. These are working models. These are not real, but working models. So these are not final systems. You can see this. Not a final system, but just a working model or working prototype. Right? So these are some experiments, experimental prototypes. Okay, you can use these prototypes. This is actually making biogas from, not biogas, actually gas from petrol. These are some samples. Just go and study. So prototype is a model. It's a working model, but not the real full system. So when requirements are not clear, you can implement a prototype and show this. This kind of thing need to be developed. It's a prototype. Right, observation, you go and see what's going on in the library. You see what's happening, what are the processes, monitor and write down. So actually, this task is done by a person called system analyst. So highlight the word system analyst. He is the person who identify the requirements and define the system. Problem definition, requirement analysis is done by the system analyst. Underline the person. What he does, go and observe, do interviews, ask questions through questionnaires, fill it and collect those data. Then documents, take the documents, read them, reports, library cards, take photos or collect them. Prototyping, a working model can be created, right? A sample, maybe sample website, a sample model can be created. That is a prototype. Then after identifying the problem, then the designing the solution. Similar to, so I said this using the example, making a house. When you need a house, you need to identify the requirement. How many floors you need, how many rooms you need, how many bathrooms, where's the kitchen, where's the toilet, all these things you need to decide. That is requirement identification. Designing, then plan it. Draw a plan. Plan need to be given to the Dasun fellows. The plan need to be given to these actual coders. That is the coding, development phase. Okay, after doing this, the planning. In planning only we learn about the tools like flowcharts, pseudocodes that we learned in planning phase. Can you remember the three control structures using pseudocodes on flowcharts? What are the three control structures that we have used? Yes? Three control structures used in flowcharts. Come on. At least send it to chat. Three control structures using program. Yes. Okay. Yes, sequence, selection, and repetition. Correct. Sequence, selection, and repetition or iteration. Sequence, instructions are executed one after another, flowing smoothly. Selection, from the alternative, select an alternative. Repetition, repeating the same thing again and again until a certain condition. So user interface identification, hardware system requirements and the requirement the design in the platform, identifying the subsystems, database design, user interface design, test planning, then flow charts, pseudocodes, state charts, class diagrams, different diagramming, all this planning happens here. It is a big pace because according to plan only the implementation happens. So planning is critical. Plan එකේදී තමයි ඔක්කොම තීරණය කරලා මෙහෙමයි වෙන්නේ කියලා ගන්න. Then the actual development, the coding happens here. Right? The coding happens here. There are tools used for coding and people are used there. Coders are used, programmers are used there. And the testing and debugging start with all three phases actually, but mentioning as the fourth phase. Because why testing and debugging is needed? So when you code, you need to test your code, whether it's working or not. When you design, you have to test your design. When you analyze the requirement, you have to test your analysis report. Testing should be there everywhere. So initial testing is unit testing. You just test small unit. Example, you are making a computer. First, you have to test the monitor. You have to test the keyboard. You have to test the mouse. You have to test the printer. You have to check the system unit, power unit. Likewise, unit by unit, you have to test. That is called unit testing. Simple. This is where the coding errors, requirement errors, planning errors are identified. Very simple. That is unit testing. Then integrated testing. You combine the modules. Monitor is connected to the system unit and then test. System unit is connected to the printer and then test. Likewise, integrated testing. Add in components and test it. That is called integrated testing. The third one is system testing. The entire system is tested. And finally, it is given to the users and acceptance testing is done. Acceptance testing done in user side or the user location. Whether they like that, any comments, etc. Individual units are tested. Yes. Integration, combined and tested. The entire system is tested. Actually, code testing is done in unit testing mostly. Code එක බලන්නේ මේකේදී. අනිත් ඒවාේ code එක නෙමෙයි input දීලා output එක තමයි බලන්නේ. Therefore, this is called black box. This is called white box. White box means you are looking at the code. Black box is you are not looking at the code. You are only considering inputs and outputs. Acceptance testing is done at the user side. Finally, the deployment. You can directly implement the system. Stop the old system. Next day onward, the new system is. This is very fast but risky. So this is how government change in Sri Lanka. Stop the projects. Next day, new government start with new projects. So all projects are gone over. So that is why. So we are here. That's why we are a third world country now. It's even below that. Direct implementation has high risk, but when system is small, possible. But when systems are large and critical, this is not recommended. You are starting the new system from the next day. Or you can run both parallelly. All system, all government is running, new government is also running. So if you can do such thing, that will be expensive in the parallel stage, but so it will be a successful turnover. It can be a successful change. Because both systems are running, you have a backup. So this is reduced risk, right? But it is costly and time consuming because both systems need to be run. Then the third one, pilot. Pilot means you take a sample and just apply this to the sample. Let's say you want to make curd from milk. So you are not going to, so since if you have not done that, you only take a small sample and test it. So that is the pilot deployment. Pilot එකේදී ඉස්සලා බලනවා පොඩි sample එකකට දාලා වැඩේ හරියනවා. හරියනවා නම් තමයි මුළු system එකටම දාන්න. Paste stage by stage. First you pasteurize the milk. Right? Next, maybe you boil the milk, pasteurize, boil the milk, boil the cans and clean it. Right? So then maybe you can keep it under the sun for drying. Then you can put this to the next stage by stage, phase by phase. So this can be done phase. Not actually, this phase can be overlapping. So this phase can be overlap, but you can do things phase by phase. Here actually you have in the pilot one, you only take sample and apply whole thing to the sample. But here you are not doing the whole thing. You do stage by stage. Stage by stage. That is phase deployment. Example, how highway is given to the us using phase development, phase by phase. Okay, then the final stage, the sixth one is the main phase. First one is problem definition, analyzing, requirement analysis. The second phase is design. Third phase is coding. The fourth phase testing. Fifth phase is deployment, and the sixth is the maintenance. Any system after some time need to be maintained. So what are the reasons? Reasons for maintaining? What do you think? So what are the reasons for maintaining a system? There are some reasons. Because time to time requirements are changing. Today's requirement is not yesterday's requirement. It can be a different set of requirements. Therefore, system need to be updated to cater those changing requirements. Sometimes hardware changes, technology changes are happening. You need to update system to adapt that. Sometimes location changes, user changes are happening. You need to adapt that as well. Sometimes new features are introduced. So likewise, different things are there in the different with the time. Therefore, the maintenance is done last. Adding new technology, adding new users, change in user requirement, change in interfaces, maybe satisfying a new requirement, change to existing requirement. All these things are coming under the maintenance. Okay, SDLC can be followed according to different models. That is our final topic today. SDLC, system development lifecycle, can be followed according to different models, and the first and foremost, the easiest is waterfall. You can see, so waterfall is falling down stage by stage without any interference, right? No collapsing, no mixing up of the stages. So once requirements are identified, after finishing that page, go to the next. After finishing the planning, go to the next. After finishing that, go to the next. But this is highly theoretical model. The reason why this is that much of theoretical, why it is highly theoretical, the reason is you can't actually develop a system like this. System. So can you exactly tell all the requirement at the very first time? Yes, for some small systems, yes. There are some systems, some traditional systems, you can define all the requirements prior to start. For this is correct. But normally, practically, this model is only applicable when requirements are clear and stable. Okay, please write down within the bracket. Applicable when the requirements are clear and stable. Applicable when the requirements are clear and stable. So please write down that. But if requirements are vague or changing, or requirements are not clear, this model is not really suitable. When requirements are not clear and requirements are changing, this model is not very suitable. Suitable only when requirements are clear and stable. This is your waterfall model. Okay, then the iterative incremental. So this is the same steps are followed again and again. You can see the planning stage, initial planning, and after that, the small planning, like according to the requirement planning, then analyzing, designing, implementation, testing, evaluation, and deployment, handover that. Again, the next requirement is taken and handover that. Next requirement. This is like continuous repetition. This is good for small systems, relatively mid-range systems, small systems, and mid-range systems, where you can deliver things pace by pace, step by step, incrementally, iteratively, repeatedly. You can add the components, iterative, incrementally. First version, the second version, third version, palani version එකේ features දෙකයි, ඊළඟ version එකේ තව එකක් ඕනි. So you can keep adding the things. The system is available initially, then make a system එක හම්බෙන්නේ අන්තිමට. After all the stages, only system is visible. Here, you can see and you can get the look and feel of the system earlier. You can get the exposure earlier, but so this will be keep incrementing. Those are the two models mentioned in your book, right? So these iterative incremental models are, so those are the things. But so I'll give you other two aspects. So what are these prototyping models? As I said, the prototype is a working model. When requirements are not clear and right, when requirements are not clear, so prototype is very good method of identifying the requirements. You can develop and show this to use that user there in it requirement මොනවද කියලා කියන්නේ. මොනවද අවශ්‍යතා හරියට ඔයාලා වගේ. ඔයාලා ඉන්නේ ගල් කිල්ල වගේ. ඒ වගේ තමයි. ඔයාලට තේරෙන්නේ නැහැ මොකද්ද මේ වෙන්නේ කියලා. එහෙම වුණාම ප්‍රශ්නයක්. මේ වගේ තමයි සමහර users ලා ඉන්නවා they can't understand what they really need. ඒගොල්ලන්ට ඕන දේ මෙයාලට තේරෙන්නේ. In that case the developers need to identify that නැත්නම් developer කරලා ඉවරනට පස්සේ users ට කිව්වොත් අනේ මට අපිට මේක එපා. මෙහෙම එකක් නෙවෙයි අපි ඉල්ලුවේ කියලා කිව්වා. හරි දැන් ඔය වෙලා තියෙන්නේ. Right? So initially people requested a hero or heroine. Now we got a person. He thinks he's a hero, but you know it's even below zero. Right? Now people are now complaining this is not the change that we have requested. Earlier they did not bother, but now they are bothering and telling, "Ayyo, meka nemeyi api illapu wenasa. We didn't request this kind of fellow." But the thing is, so the development party cannot deny. Development party maybe the particular person is telling, "No, I am the person that you have requested." There is ambiguity. That problem can happen. Therefore, before actually implementing, prototype need to be developed. In such cases, when requirements are not clear, the working model of the prototype need to be developed. And if you like, if users like that, we can continue to do it. And spiral model is quite similar to iterative model, but not the same. Spiral model is mainly focusing on risk reduction. For critical systems, spiral model is very, very useful. So let me write down. Critical systems, critical and complex systems having higher risk can use this spiral model. Critical and complex systems having higher risk can use the spiral model. Because this, like spiral model, let me show that, because it is not explained in the book. Let me show that. In the spiral model, so the main focus is given to reduce and resolve the risk. You can see determining objectives and alternative solutions. So this is where the feasibility study is done, finding the alternative and the best alternative is selected from there, and then identifying the risk is done. So after identifying the risk, it will be resolved and develop the next level of the product, and the next phase is planned and review is done for the developed component. So likewise, it's going iteratively, again iterative model, but this mainly focuses, this has main areas, that is risk reduction. So that is the main concern. Risk analysis, risk planning, risk reduction, that is the main concern. So therefore, this is good for the critical systems. Okay, with that, our discussion is done, I guess. We have discussed about the basic, what is system. Then we identified different system development life cycle models, as well as we have identified the main components, data, process, information of the information system, as well as any general system has input, process, output. We identified that, and also identify the stages of SDLC, 6 stages clearly. We identified that can be very different places, but mainly these 6 are anyway there. So then discuss about the man-made systems, natural systems, different type of systems and their usages and what is system. So with that, the particular lesson is done. Internet and email I have finished last day. I think some of you guys missed it. Then I'll be moving to multimedia lessons. But for today, I'll be stopping here. Next day, I'll be moving to multimedia because we have enough time. So I'll be moving to that lesson next day. This is also a practical lesson, highly practical lessons. I'll be discussing that with the practical tools. So please go through that and install in your computer. Please install GIMP 2.0, 2.8. This is required. Audacity, if you don't have, please install Audacity as well. And there is an animation tool. The tool name is here. You can see Vectorian Jito. So install Vectorian Jito as well. That is for animations. Looks like Flash. So please install this software in your computer because we need these practical things to be done during this lesson. Okay, then good night. See you next week.